Let's move on to question number 4 from section 8.1. And for all the problems on question number 4 here, these are all multi-step problems where you need to find the length of AB. And for question 4a, the length of AB is just this red line right here. It's called AB because one end you have an A and the other end you have a B. So we'll call that AB. All right, in order to get started with this problem here, I recommend that we do find the length of this blue line right here. And since I have an A here and a D here, we'll call this length AD. Okay, so let's go ahead and work with this smaller triangle first. And our goal is to find AD first. If I look at AD, and it's directly across the 90-degree box here, so this right here is your hypotenuse. And if I look at the 28 degrees, if I look at the other end here, the 6 is your opposite, right? So your 6 millimeters is your opposite. Okay, so we're given the opposite and we're given the hypotenuse. So the trig function that relates the opposite and the hypotenuse is your sine function. So it's always sine of the angle. So the angle that I'm working with in this problem is 28 degrees. So sine of 28 degrees. And that's going to equal to, I need my opposite first. And my opposite is going to be 6 millimeters. And my hypotenuse is going to be AD. So our goal now is I need to solve for AD. And you can do that by simply interchanging sine 28 degrees with AD. So you can just switch these two terms there, or those expressions. So AD will be on the top left now, and sine 28 degrees will be on the bottom. So sine of 28 degrees. And then from there, you would go to your calculator and type in or input 6 divided by sine of 28 degrees, and you get 12.8 millimeters. Okay, going back to my original diagram here, let me just erase some of this stuff here. 12.8 is this length, this blue line here, so that's 12.8. And our goal, remember, is to find the length of AB, which is that red line right there, right? So our goal is to find AB. Now, if I look at the bigger triangle now, the bigger triangle, which I'm trying to like highlight in the colors here, the AB is really your hypotenuse, right? It's directly across the 90-degree box, so that's your hypotenuse. And since you're given 36 degrees, you notice that the 12.8 is right next to the 36 degrees, so this is your adjacent. So the 12.8 is your adjacent. Okay, so I'm given the adjacent, and I'm also given the hypotenuse, and the trig function that relates the adjacent and the hypotenuse is the cos function, right? So it's always cos of the angle, and my angle here is 36 degrees. And now I need my adjacent. My adjacent is 12.8, and my hypotenuse is AB, right? And our goal is I need to solve for AB. And just like the previous problem, I can take the AB and the cos of the angle here and just switch them. So AB is 12.8 divided by cos of 36 degrees. And if you go to your calculator, that should give you a final answer of 15.8 millimeters. And that would be your final answer for that problem. Okay, let's move on to the next question here. I believe we're now moving on to question 4b now. Now for 4b, the goal is that we need to find the length of AB over here. So before we do that, we would probably need to work with the two smaller triangles here. And just like the previous problem, you want to find the value of AD first. Okay, and then after you do that, you would probably need to work on this other triangle here in pink. And I recommend that you look for the value of BD as well. So if you have AD and BD, you can definitely find the value of AB at the very end there. Okay, so how do you find the value of AD, which is in blue? Okay, well, if I look directly across here, this is your hypotenuse. And this 45 is actually your adjacent, right? So since the 45 is right next to the 35 degrees, that's your adjacent. So you're given the adjacent and the hypotenuse. So the trig function that relates that will be your cos function. So if I look at cos of the angle, so cos of 35 degrees, that's going to be your adjacent, which is 45. And then I divide by my hypotenuse, which is going to be AD. So we can find AD, just like in problem 4a, by just switching these two terms here. So AD will now be 45 divided by cos of 35 degrees. And if you go your calculator to one decimal place, you get 54.9 meters. So AD has a value of 54.9 meters. So I'll say that for now, and we'll come back to that a little bit later. Now, looking at the pink triangle, one thing that you might want to do here is, let me just erase all this. You might want to find this angle right here in light blue. All right, so I know I'm given 35 degrees. I know this is 90 degrees. If I look at this entire angle here in general, that whole angle there adds up to 180 degrees. So if I take 180 degrees, take away the 90 and the 35, that will give me the missing angle there, right? So I get a value of 55 degrees there. So let's go ahead and plug in the 55 degrees first. So this is going to be 55 degrees. And what I want to do now is I want to find the length of this pink line here, which is a BD. So what's the value of BD there? Okay, great. All right, so let's go ahead and break it down. So if I look at this triangle here, the pink triangle, I know BD is now called your hypotenuse, right? And if I take a look at the 55 degrees, the 30 millimeters is right next to the 55 degrees, so this is your adjacent. So once again, I have my adjacent and I have my hypotenuse. So the trig function that relates the adjacent and the hypotenuse together is cos. So it's going to be cos of the angle, and my angle here is now 55 degrees, right? It's the 55 degrees, and I need my adjacent, which is going to be 30. And now I need my hypotenuse, which is going to be BD. Okay, so now I can find the value of BD by taking this and just switching those up. So BD will now be in the top left, 30 will remain the same, and the cos of 55 degrees will be on the bottom now. Now go in your calculator now, if you do 30 divided by cos of 55 degrees, you get 52.3. Okay, so let me go back and box these two. There's a 52.3 and there's also a 54.9. Okay, so now going back to my triangle here, or my original drawing, let me just erase all this. I know that this is going to be a 54.9, and I also know that this is going to be 52.3. All right, so I'm given the two legs of this triangle. And remember, we need to find the length of AB here, and since AB is your hypotenuse and we're given the two legs, when I mean legs, I mean these are the legs of the triangle right here, right? So now you can use the Pythagorean theorem now to find the value of AB. Okay, so let's find the value of AB here. So using the Pythagorean theorem, you take your legs, 54.9, and you square them. So now the other leg is 52.3 squared, and that will equal to your hypotenuse, which is AB, right? So in the formulas, it's usually written like something like this: a squared plus b squared equals to c squared. So my legs are 54.9 and 52.3, and my hypotenuse is AB. If you go to your calculator and input all this stuff here in green into your calculator, I get a value of 5749.3, and that equals to AB squared. And then after that, you just want to take the square root of both sides. If you take the square root of the right-hand side, you just get AB. And the square root of 5,749.3 is roughly about 75.8, and then units are meters. So my final answer is about 75.8 there. Okay, let's move on to the next question in the homework here. I believe the next question is going to be D. Okay, so for letter D, the goal is I need to find the length of AB, which is right there. So I recommend that you'd find this blue length right there, and then after that find this pink length, and if you add blue plus pink, you would get red, right? So that is the approach for this particular problem here. Okay, so looking at, let me just erase this here. Let's take a look at this smaller triangle here. Okay, so I know that this right here, the 6 feet, compared to the 65 degrees, that's going to be your opposite, right? And I need to find this short distance right here. I'll call that x. So x would be your adjacent because it's right next to the 65 degrees. Okay, so I'm given the opposite and I'm given the adjacent, right? So the trig function that relates opposite and adjacent is your tan function. All right, so I need tan of the angle, so tan of 65 degrees. And the opposite comes first, and the opposite is going to be 6 feet divided by the adjacent, and the adjacent here is going to be x, right? So I have tan 65 degrees equals to 6 over x. Now we've seen this kind of a problem before, and I take these two pieces, which I'm highlighting out in yellow, and you just switch them, right? So x would equal to 6 over tan of 65 degrees. And just go to your calculator, and you should get about 2.8 feet. Okay, so if I go back to my diagram here, let's just figure out what does 2.8 mean. 2.8 is just this distance right here in pink, right? So that's going to be 2.8. Okay, after that, let's take a look at this red triangle right here. And my goal now is I want to find this distance here. I'll call that y. So y goes from there to there. Let's find that distance y. And if I look at my triangle here, the 6 feet here, that's going to be your opposite, right? And since y is right next to the 46 degrees, this is your adjacent. So I have my adjacent and I have my opposite, and the trig function that relates opposite and adjacent is going to be the tan function, right? Sorry, tan, right? So tan goes TOA. So the trig function that has opposite and adjacent is the tan function. Okay, so I need tan of 46 degrees. Sometimes I have a bad habit of going from a small letter to capital letters. Since I use capital letters, I'll use capital letters for this problem. So tan of 46 degrees. I need my opposite first. Now my opposite is going to be 6, right? So 6 divided by my adjacent, and my adjacent is y. And just like the previous problem, I can switch those two terms. So y would equal to 6 over tan of 46 degrees. And if I go to my calculator, 6 divided by tan of 46 degrees is 5.79. Okay, so going back to my diagram here, let's just figure out what we just found here. So this distance here in red, that's going to be 5.79. So what we do now is I just take my 2.8 and my 5.79 and I just add them together, right? So 2.80 plus 5.79, if I add that together, I get about 8.6 feet, which is the length of AB. Okay, let's go on to the very last problem for this homework video guide, and that's letter E here. So letter E, it's not too bad because we're given the 47 degrees, and we know this is 90 degrees. Let's go ahead and find this corner angle right there. If I do my whole 180 degrees minus 47 degrees minus 90 degrees, I should get a value of 43 degrees, right? So this corner angle here is 43 degrees. Once I know that's 43 degrees, you should be able to find this angle right here, right? Because these two orange angles add up to 90 degrees. So if I do 90 minus 43, I get 47 degrees. So this right here is going to be 47 degrees. Okay, sorry about that. And the goal now is I need to find the length of AB, which is this length right there. Okay, let me just kind of, let me see if I can blow up this triangle here. Oops, that didn't work. Okay, that might be good enough. Okay, so taking a look at my triangle here, this triangle in blue here. I gotta find the value of AB, which is like this x value, right? So given that we have 47 degrees in the corner there, this right here is your opposite, and the x right here, which is representing AB, this is your hypotenuse, right? So I'm given the opposite and the hypotenuse, and the trig function that relates that is going to be sine, right? So sine of 47 degrees is the opposite, which is now 22, divided by the hypotenuse, which is x, right? And from there on, we've seen this a few times here, just switch those two expressions. So x would equal to 22 divided by sine 47 degrees. And if I do 22 divided by sine 47, I get about 30.1, and my units are yards. Okay, so that's how you do question number 4E, and that concludes this homework video guide.